All right, today we're going to look at sine and cosine functions and two uh, important things about wave functions, which are called, you might remember it from physics, there's the amplitude and the period. So let's look at this sine function here. This is a sine function. Let's just check. We've got the unit circle next to us here. See that the sine function starts at 0, goes up to 1, back to 0, down to -1. When it gets to 2 pi, full circle, it comes back to 0. So let's look at the unit circle. We're looking at the sine. And the sine starts at 0. And as we go around, it gets up to 1, and it goes to 0, -1, and 0. So that's what our sine function is, just like on the unit circle. So if we look at our sine function here, let's go and put the important things that you've already learned in physics, but let me just put them on here again. The period is what we call the period. That's the range of x values, the range of values in the domain during which the function itself is periodic. So here it goes through a period, and then it does the same thing again. That becomes another period. By the way, you could start it here and go to here. It's wherever you go from here to here. It's the distance in here from any point on this curve to the same point where the same pattern starts again. Okay, funny thing here. Take it out and go away, green dot. Wow. All right. And the other thing is what we call the amplitude, and that would be the distance, the biggest, write down amplitude, this, the biggest absolute y value that we get. In this case, for example, here we go from the x-axis all the way up to here, that's the amplitude. It also goes from here down to here by the same amount. So the biggest distance from the x-axis in the y direction is the amplitude. All right, now let's just think about this, a few things with the amplitude and the I'm going to change colors here. I'm going to go to this kind of funny blue. All right, so if I say y equals the sine of x, that's what I'm looking right here on this curve. What if I said y equals minus the sine of x? What would that look like? Well, if I take this point here, minus that would be down here. If I took this point here, it would still be 0. If I took this point, it would still be 0. If I took this point here, it would be up here. So it would kind of flip it over, right? It would look like this, and so on. What about if I had y equals sine of minus x? This is an interesting one. So suppose that I flipped not the result of the function, but the input to the function. Well, let's think about that. If I go over here on my unit circle, sine is the y coordinate. So as I go up to here, the y coordinate here, if I go positive, it's 1. But if I go negative, it's -1. If I go positive here, it gets to 0. If I go negative here, it gets to 0. If I go positive 3/4 of the circle, I get to -1. If I go -3/4 of the circle, I get the positive 1. So again, the because it's the y coordinate, it would be the same thing. It would be the same thing. It would flip the same way. It would flip the same way. In other words, these two guys here, I'll let you think about that. You can go back and think about it, go over the unit circle by yourselves. But these two would look exactly the same. Okay? Now, what if we try to fiddle? Something else? Let's try and fiddle something else. I'm going to do it in green. Y equals 2 times the sine of x. Let's think about that. If I'm here, 2 times 0 is going to be 0. If I'm here, 2 times 0 is going to, 2 times 1 is going to be up here. And if I'm 0, it comes back here. If I get to 3 pi over 2, it's going to come down here. So I'm kind of like increasing, I multiply by 2, I'm increasing the amplitude. In fact, what I'm doing, think about it, is for every point on the red line, I'm multiplying by 2, and I'm getting to the green line. That's what happens when I use this 2 here. And what about the other way around? What if I did y equals sine of 2x? I'm going to change colors for this. I'm going to use black for this one. All right. So here, if x, sine of 2x, if x was pi, then the sine of 2 pi would be here as well, because that's what's over here, right? And the sine for pi over 2, well, here with 2 pi. If x was pi over 2, then 2 times pi over 2 would be pi, which means that here we would get what we normally get at pi. So that's also going to be 0. What about if we're halfway between pi over 2? If we're halfway between pi over 2 and 0, then my 2x would make it pi over 2. So what's normally here would be over here. So let me draw a dot here. What happened there? I lost everything for a second there. All right. So that would be here. So we were. And again, if it was 3 pi over 2, then it would come to here. It'd be like this. So I'll let you think about this and go back and go over it, see if you agree with that. But basically, by multiplying my input by 2, I'm able to squish 2 full periods into 1 2 pi, because each of the values becomes double as big. So it's kind of like it's pushing. What happens is it pushes my red line everywhere that I have a red. It pushes it halfway back to the y-axis, right? So I squish. So when I do this, when I multiply the whole thing by 2, it fiddles with the amplitude, and when I multiply the input by 2, it squishes the period. Let's see if we can have a look at that on GeoGebra. Here I've got a sine function. This is what we're looking at, sine of x, and here it goes in a period of 2 pi. What if I look at sine of x, like as it flips it upside down, and as we saw, sine of minus x is the same thing, different color, there it is, it's the same. Sine of minus x and minus sine of x are the same. Okay, let me turn those off. Now let's go and look at 2 sine of x. We got 2 sine of x here, and that's going to push up the amplitude. Now here I've done a cool thing. I've done a sine of x, and up here I've got a equals something. So I'm gonna change this to 2. All right. So now we've got a is 2. So if a is 2, then it's 2 sine of x, and I get my 2 sine of x, right? I've pushed the amplitude up by 2. But now I've got this slider here, and I can make it run up to 3 and down to -3, and that's going to change a, and that's going to change the amplitude. Let's watch what happens. As it goes down, the amplitude goes down, and then as it passes to negative, it's going to go all the way to -3, right? -3 here. Now it's coming back up, It's going to go all the way up to 3. It's going to get up to 3 times the normal 1. So by fiddling with A here, stop this guy. Stop it. So at 2.1, the amplitude is 2.1 what it normally is. All right, and now let's look at here. What I've done is I've got sine of 2x, and we said that would fit 2 periods into the 2 pi. See? Boom, there it is, 2 periods into the 2 pi. And now if I do sine of bx and I fiddle with b, see what happens? As b gets smaller, and it even goes completely flat and comes negative. When b is 0, obviously everything is 0. And so by fiddling with the coefficient inside the parentheses here, we're squishing or unsquishing the period. Obviously, if it goes below 1, then it unsquishes it. Bing, there we go. Stop it below 1. Let's see. Stop this. If I go just like a half. If I go to a half, I go to a half, I go to half, then I've doubled the period. See, it does half a period where the red one does 1 period. All right, so that's it for the sine. In the next function, we'll do the same thing for the cosine.